Yes, sir, you're audible to me.
Okay, okay, thank you. Uh, Mr. Piyush, the UK founder and director of New OSA Medicube Private Limited Company, incubated at VNIT Nagpur and mentored by Venture Center Pune. He has more than 10 years of experience in the domain of 3D printing for biomedical applications. He has completed his diploma in mechanical engineering from Anjuman Polytechnic Nagpur, BE from Priyadarshini College of Engineering Nagpur, and MTech in CAD/CAM from PDPM IIT DM Jabalpur. Uh, his key research area is adaptive manufacturing, product designing for biomedical domain, FEA, CAD/CAM, anatomical modeling, and product development. He is also actively working towards educating youth with latest cutting edge technologies and has conducted and coordinated various workshops, seminars, short term courses related to 3D printing and product development. He is being invited as a person in various SSTPs and FDPs at various IITs and NITs and engineering colleges. He has published more than 12 research papers and granted 2 patents. Moreover, Piyush has received highly competitive BIRAK Big Award of 50 lakhs for developing POC of artificial temporal bone in 2020. He is passionate to work in the field of 3D printing and other advanced technologies, assure you OSA in working in proper and focused way. Uh, Over to you, sir. I think you have already joined.
Yes, sir. Hello, am I audible to you, sir?
Yes, sir. Yes, sir. You are audible.
Yeah. Thank you for the introduction, sir.
Thank you,
So,
sir.
yes, I would like to take this opportunity to move forward with the session. So today, in today's session, we will be discussing more about the sustainability of additive manufacturing compared to the conventional manufacturing process. So how 3D printing is sustainable and like what are the different ways by which conventional process works and how we can overcome the sustainable issues which are there with the conventional process, how we can overcome those issues with the additive manufacturing. So I'll try to keep my lecture in a brief way about the same process. So with this, I would like to continue with the session. First of all, I'll share the screen. Yeah. But to you, sir? Hello.
Yes, sir. Yes, sir.
Yeah. Thank you, sir. Can you see the slides, sir?
Yes, sir. Yes, sir.
Yeah. Thank you. Thank you so much, sir. So let's begin with today's session. So I'll begin with the question. So I'll begin with the question. So what do you think? Is current manufacturing process sustainable? You can write in the chat box if you want. So obviously, like current manufacturing process is not sustainable. So if we talk about the problems associated with the current environmental problem, so like carbon emission is one of the major problem with the conventional process. Even the plastic waste or the waste which has been collected after the manufacturing process, that itself is one of the major challenging tasks. And then wastage of water, like water pollution is also one of the major issue with the industrial production. Like wastewater has been the wastewater has been what we can say is it has been deposited into the river, which pollutes the water. So these are one of the major issues which are there because of the current conventional manufacturing processes. And if we want to make something sustainable, so we need to cater we need to cater all these issues, then only we can make the sustainable process. So there are many challenges associated with the sustainability, like unsustainable raw material is there. Even manufacturing inefficiency is there a lot. Even the impact of impact of plastic waste is also one of the major issue for the sustainability. So around 98% of the single-use plastic has been processed from the fossil fuel. Like current, if we talk about the current plastic which has mostly been used, like ABS, nylon, PP. So these plastics are being produced from the fossil fuel. They are not being manufactured from any plant based like PLA, which is a plant-based plastic, and which accumulated around 90% of the total global carbon budget due to the fossil fuel. And manufacturing inefficiency is like 66% of the energy is being used by injection molding operation, which is used to process the polymer. And two processes use the most energies are like heating the plastic and running the mold cycle. So this two process almost all use the major energy which has been consumed by the manufacturing process. And the more the energy we consume, the more carbon is going to be deposited into the environment. And around, if we talk about the waste plastics, so 75% of the waste plastic end up in the landfill. Like we mostly use the one-time plastic. Like many times we like most of the time when we visit any market to purchase the vegetable, we hardly carry bag with us. So every time like we go to the market, ask the vendor to give us a carry bags. So we take those carry bags. Once we reached home, we take out the vegetable from the carry bag and throw the carry bag into the dustbin, which ends up in the landfill. We hardly reuse the plastic or recycle the plastic. So there are around 12 billion metric tons of plastic waste, which has been expected in the landfill by 2050. So in order to make the world more and more sustainable, we need to cater all these challenges which are there with the sustainability. And how to tackle this problem? We can tackle the problem by using the resources more and more sustainably. Okay, to use the resources more sustainably, we should always follow 5C approach, which is clean, community, culture, care, and corporate governance. So this 5Cs, if we follow this 5C, we can optimize the use of the resources which are being needed in the manufacturing sector, thus make our world more and more sustainable to live. Because what is happening, like with the current setup, what we are living, so the more and more carbon deposit, we are polluting the world quite in a very bigger way. So the upcoming generation may not have the cleaner environment what we had. Our ancestor, they had one of the most cleanest environment to live in, and we are living in the in not the most, but at least polluted environment where we don't have a filtered or a clean air to breathe as well. And maybe if we continue with the same process, with the same attitude, then our future generation, they will live in the worst condition what we are currently living in. So in order to make the things more and more sustainable, to reduce the effect on impact on the environment, we should follow this 5C approach. Okay, so now coming to the main question, what exactly is sustainable manufacturing? So sustainable manufacturing is nothing but a process by which we can create a product by using the resources sustainably, by optimizing, by using the optimized resources. So like for example, if we can make something which can reduce the carbon footprint into the environment, which can reduce the waste on the environment, if we can recycle the material and use that material into the environment, so ultimately it reduces the overall load on the environment. So that's what is sustainable manufacturing. So it is nothing but the optimum use of resources to manufacture something is known as sustainable manufacturing. Okay, so in sustainable manufacturing we can work in four areas, like we can optimize the resources, we can reduce the waste in the product, we can reduce the waste, we can make the process more and more energy efficient, and we can make more and more sustainable product, like we can recycle the product and we can make the things more and more sustainable. So if we talk about the goals of sustainable manufacturing, so the goals are like reduce environmental impact, we can converse the resources, like optimum use of energy, raw material, and other resources which are being needed. We can improve the safety, and we can improve the overall efficiency of the workplace as well as the product. Okay, so these should be the goals of the sustainable manufacturing. So this is all about the sustainable manufacturing. Now coming to the next question, that is what exactly are the different manufacturing processes. So suppose like this is the part which we want to make. If I want to make this part in the manufacturing process, so basically we have three manufacturing process. So the first one is the formative process, which is then second one is a subtractive process, and the third is the additive process. So in formative process, we need a mold in which the molten plastic will flow inside, and once the plastic is solidified inside the mold, then we will open the mold and remove the part from the mold. So here initially nothing is going to be there. The raw material, like only the mold is going to be there. The raw material will be in the form of a liquid, which will be poured into the model, into the mold, and finally we will receive the end part. So this process is like with the in this process, the minimum wastage of raw material is going to be there. Okay, but if we talk about the sustainability by using this process, so here we have like the first thing, we need to prepare the mold. In order to make the mold, certain kind of resources are going to be needed, like the mold will be made with the metal, so the subtractive machining process will be done there, or maybe casting can be is going to be done there to prepare the mold. Once the mold is been prepared, then mold assembly is going to be there, and then we again need to heat the plastic, melt the plastic, and make the plastic flow into the mold. So here, if we talk about the overall use of resources, so we can bifurcate the use of resources into two categories. The first one is the mold preparation, and second was the converting, heating the polymer and getting it poured into the mold and getting out the final part. So these two are the area where key resources are going to be used, which makes the formative process a very highly resource used process. But if we talk about a subtractive kind of process, initially we are going to have a block kind of thing. So this block, we are going to remove the material by using the cutting operation or the milling operation, and then once the material has been removed from the block, then we are going to get a final part. So in this process, initially the block will be there. From the block we will carve the final part, and the remaining part will be removed as a waste material. So subtractive process is the waste generative process, whereas formative process, the waste generation is quite less as compared to the subtractive process. But if we talk about the overall resources which are being needed to make the part is medium as compared to the formative process, because here the resources what are being used is only with the cutting operation. So once we have the mold, then we will remove the excessive part from the material and get the final part. So very less resources will be needed as compared to the formative process. And then coming to the additive process, in additive process, initially we are not going to have anything on the bed. We are going to fabricate the product layer by layer. As we can see here, the part has been fabricated layer by layer. Okay, so finally we are going to get the part. So additive is the process in which the resources are being used very less. So these are the manufacturing process. Like if you want to make the this kind of block structure, so these are the process by how we can make the part. Okay. So if we talk about our sustainability, so which process is more sustainable? So if I talk about the formative process, the resources consumption is quite high, because we are going to use the resources in making the mold as well as the making the part, melting the plastic, pouring the molten plastic into the mold, and getting out the final part. So the resources consumption is quite high. If we talk about a formative process, then the resources consumption is medium, because the resource will be needed only to run the CNC machine, and to make the initial raw material also, the resources are going to be used there. And coming towards the additive process, so this is one of the least resource consumption process. So out of these three process, if I try to draw the comparison, so we can easily say that in terms of resource consumption, additive manufacturing is one of the most sustainable process as compared to the other two processes. So what exactly is additive manufacturing? So additive manufacturing is nothing but fabricating the part layer upon layer by stacking each model, each layer one above other. So in additive manufacturing, it's a process of converting any digital design into a real-time physical object. Okay, as we can see in the video, the part has been fabricated layer by layer. Initially, we have nothing on the bed, but slowly, gradually, after printing each and every layer, the part layers are being added one above other, and finally, we are going to get the end product. So this is the additive manufacturing. If we talk about the process chain of additive manufacturing, so the process chain is like, we initially need the CAD model. Once we have the CAD model, then we are going to convert the CAD model into an STL file, which is also known as the tessellation. Then slicing of the STL model is going to be done, followed by toolpath generation and support generation. Once the toolpath has been generated, then we are going to transfer the toolpath or the G codes. Like we will save the toolpath in terms of G code, and then this G code will be transferred to the 3D printer either by using pen drive or by using memory card, whatever the system supports. So based on those transferring medium, we just need to transfer the G code into the transferring medium, and then the transferring medium can be loaded into the 3D printer, and 3D printer will print the part accordingly. And then once the part has been printed, then we need to do the post processing. In post processing, we need to remove the support removal is going to be there. Even if we want certain kind of surface finishing operations needs to be performed, so those surface finishing operations are also going to be performed there in the post processing. So this is the overall process chain of additive manufacturing. Like, even if we try to classify the additive manufacturing into different kind of technological classification, so we have around 14 to 18 types of additive manufacturing processes which are there. And all the additive manufacturing process, despite of the technology what has been used in additive manufacturing, this basic process chain will be followed by every technique of 3D printing. So coming,
good catch.
Dear participant, kindly mute yourself. Sharma,
कहाँ लगी कोई बात नहीं
Sharma, Sharma, please mute yourself. Yes, sir. Continue, please. Sir, I think you are muted. Please unmute yourself.
okay, am I audible, sir?
Yes, you can continue.
Yeah, thank you. So coming towards the type of additive manufacturing process, so we can categorize the additive manufacturing process into three basic type of additive manufacturing process based on the type of material which have been used, like liquid, solid, and powder. So these three are the basic categories in which the additive manufacturing can be classified. And among all these three techniques, we have again the sub classification of the technique, like SLA is there, SLA is there, SLS is there. If we talk about the first process, that is stereolithography. So stereolithography is a liquid type 3D printing process. Then selective laser sintering is a powder based process. Then we have a fuse deposition modeling technique, which is a solid based process. Then digital light process, print DLP printing is there, which is again a liquid type 3D printing process. Then multi-jet fusion technique is there, which comes under the powder jet technique. Then we have a polyjet technique, which comes under the liquid 3D printing technique. And we have a direct laser sintering and electron beam melting process. So these last two are the metal 3D printing process, and remaining of all the processes which have been mentioned here are the polymeric 3D printing processes. Okay. So now among all these processes, the most commonly used 3D printing process is FDM and SLA. So these two are the SLA oblique DLP. So these two are the process which are most commonly and most widely used in the sector. Like even if you have a 3D printer at your institute or at your facility, so that might be that might be either FDM or DLP, SLA DLP. Or then after these two process, then comes the SLS. But SLS facility, very few institutes are there who has SLS facility, but almost all 95% of the institute, 90 to 95% of the institute, they definitely have either FDM or SLA DLP. So this technique we are always going to find in the institutes. Okay, so I try to explain you the FDM as well as the SLS and DLP, SLA and DLP process. So I'll try to explain you these two processes. So coming towards the first process, which is an FDM kind of 3D printing, FDM kind of 3D printing process. So in FDM 3D printing process, the material will be in the form of wire. So like here we can see two wires are being fed into the extruder system. The dark blue is the main material and the light material. Each material is nothing but the supporting material. So we can feed this material into the extruder head in the form of where the material will be heated into the extruder nozzle assembly. So this is the number 4. This is the extruder nozzle assembly, where the filament is going to be heated, where the material will be heated, and finally the material will be extruded from the nozzle. So the nozzle will move in x direction, as here we can see in the image. This is the nozzle tip from where the material has been extruded. So the nozzle is moving in y direction. This is the bed moving in z direction. So once the layer has been printed, once one of the layers has been printed, then the bed will move downward subsequently, and the successive layer will be printed there. So this is how the FDM 3D printing process will take place. Then if we talk about the SLA DLP process, in SLA DLP process is also like the working principle is like here we will be using a photopolymeric resin which photopolymeric resin in the form of a liquid, which will cure once the liquid has been exposed to the UV light. So here, in order to start a polymerization, the material have to be exposed to the UV light. So the exposure of the UV light can be in the form of a laser light, as you can see here in the image. It can be either in the form of the laser light, or it can be like we can eliminate the entire layer to the bed. So if you're illuminating the entire layer onto the bed, then it is known as a DLP kind of 3D printing process. And if we're only illuminating the laser light, the point laser has been used to cure the material, then it is known as a SLA technique. So the process is like once this photopolymeric resin will be exposed to the UV light, the laser will follow the tool path which has been generated while the slicing, and according to the G code, the laser will follow the tool path and the material will start getting cured. Whereas in DLP, the entire layer will be projected at once, and then the whole layer will be cured, whole layer will be converted into a solid form. Then the bed will move downward, as here we can see in the video. Once single is printed, and then fresh resin will come in between, and again the same layer will be illuminated. So this is how DLP works. So the basic difference between SLA and DLP is like in SLA, point laser will be used to cure the material, whereas in DLP, the entire layer will be projected at once to cure the layer. So if we talk about the speed, obviously in DLP, since we are illuminating the entire layer at once, so DLP is quite faster as compared to the SLA process. So these are all the SLA and DLP. So if you talk about the current scenario in additive manufacturing, so we can use the additive manufacturing to develop the prosthetic limbs and other body parts. Like in the image, we can see the boy doesn't have a hand, okay, doesn't have a left hand side hand. So if you want to make, like if you want to make such kind of prosthetics for the patient specific prosthetics, so that we can make by using 3D printing process. So the process of developing the prosthesis is quite easy as compared to the conventional one. If we talk about the conventional process, in conventional process, first we need to make the mold of the patient. Once the mold has been prepared, then that mold will be used to make the final cast of the prosthetics, and then the final cast of the prosthetic will undergo some kind of finishing operation and post processing operation, and later on the part is going to be delivered to the patient. But if we talk about a 3D printing process, in 3D printing, we can do this scanning hand. Like suppose if we put a patient, we can scan this area, we can do 3D scanning of this hand area, and then we can convert the 3D scan directly into a 3D CAD model. Then that we use to design prosthetic prosthetic virtually. So we can create a virtual assembly of the prosthetic onto the hand, do some fine tuning design if needed for the proper fitment of the model to the patient. And once we do this design modification and design iteration, then we are going to directly print the prosthetic and give it to the patient. So likewise, we can reduce the overall product development time with the 3D printing technique. The another one is the home and house building, like construction. Now 3D printing is widely being used for the construction industry. Like in India, there are few startups who are actually working in this sector. And L&T is also one of the first company who is trying to get this thing trying to get this thing commercial into the market. So this is also one of the which have very good potential to the market. Then we can use 3D printing for printing. Like food industry is also trying to 3D printing a lot. So they're also trying to make the part with optimum kind of material, with the optimum kind of resources which are being needed. And with 3D printing, it's like since they can make many creative shapes in the chocolate or the cream toppings. So they have a design freedom with the 3D printing. So they can make complicated shape with the 3D printing. Yeah. Then we can use 3D printing in the manufacturing. So now 3D printing is like from prototyping, 3D printing is shifting towards the manufacturing goal. Now many people are shifting towards the manufacturing. Like if we talk about the space industry, so space industry they're using 3D printing a lot into the manufacturing process to make their actual end components. Like initially, if we talk about the 1990s or 2000s, when 3D printing was actually introduced into the market, so at that time 3D printing was mostly been used to develop the prototypes. But now the shift can be seen, like the 3D printing is shifting from the prototyping towards the end user manufacturing. Okay. Then we can make such kind of complicated shape. Whatever comes into the mind, we can make by using 3D printing. So this is one of the good tool with the designers to make something creative out of their mind. And such kind of complicated structure is impossible to manufacture by using conventional process. Like we cannot manufacture this part with the conventional. We cannot do casting of this model, we cannot do CNC machining of the model, even we cannot do injection molding of the model. So this is one of this kind of structure are quite complicated to manufacture. So for such kind of structures, 3D printing comes into the rescue, and 3D printing is the only option which we can use to manufacture the parts. Then we have a design freedom. So this is the example of a fuel injector nozzle which has been used in one of the aircraft. So initially they used to make this fuel injection nozzle in a different smaller components, and later on they used to assemble all the component all together, and the final fuel injector assembly was used in the aircraft. And now they have reduced the all the number of components into a single component, and they are manufacturing the entire part as a 3D printed in a single component. So the beauty is, like, since we have reduced the component, so we have reduced the weight, and with reduce the weight, we have increased the overall efficiency of the part. So the fuel efficient, by reducing the weight, we can obviously, since we're talking about aircrafts, even in the aircraft, if we could save 1 kg of the load, so we are going to obviously we are going to increase the overall efficiency of the aircraft. So with this kind of structure, they have increased the overall efficiency, the fuel economy of the aircrafts. Then we can work with the weight reduction kind of model. Like, suppose this is the original model which needs to be manufactured. So due to the shape and size constraints, so we got the outside the outward convex hull of the model. So the overall, we know the maximum x, maximum y, and maximum z dimension of the model, and which we cannot change due to certain kind of design constraint. So if we are going to manufacture it by using CNC or any conventional process, so we due to the design shape and size constraint, so this is the model which sorry so this is the model which is going to be manufactured, and this model is not going to be the weight of optimized weight kind of model, since it's a quite big, quite bulky, so weight optimization is not there. But then we can do the design topology optimization, and we can optimize the overall part into the this kind of structure, where we can remove the material from the excessive part, wherever we can save the material, like which has a where we don't need much strength from those area, we can remove the material, and wherever the strength has been needed, there we can add the material. So this is how we can optimize the overall topology of the design, and we can reduce the weight. Then we can use the 3D printing for the customization. So like customization of the hearing aid is also possible with 3D printing. So this is the example of a conventional process, where if someone wants to manufacture the hearing aid for the patient, so first of all they'll pour the silicone into the ear, and then this kind of pattern will be manufactured first. Then this pattern will be used to make the mold, to make the mold of the hearing aid, and that again the enclosure will be produced, and that enclosure will be assembled with the electronic component, and final hearing aid will be delivered to the patient. But with the use of 3D printing, instead of pouring silicone and making the pattern, we can directly 3D scan the ear of the patient, and once we 3D scan the ear of the patient, then we can once we have the 3D scanning, we can generate, or we will have the 3D CAD model of the ear. And once we have the 3D CAD model of the ear, then we can directly design this kind of enclosure or this kind of enclosure virtually. We can do the virtual fitment there itself. We can make the design more optimized, more economical. And once we have those optimized design, then we are going to manufacture the design with the 3D printing process. Again, we can, and the last example is like we can use the 3D printing for developing the optimum heat exchangers. So this is one of the example of a heat exchanger, where we can actually reduce the weight from the centric part, where the weight reduction can be done by optimizing the overall density of the part. So again, if we are reducing the weight of the part, so obviously like less energy needed to make the part, and ultimately we can save a lot more of energy and a lot more of carbon deposition into the environment. Okay, so these are the current scenarios where additive manufacturing is mostly used. So coming towards the benefit of additive manufacturing, so we can use the additive manufacturing for batch production. Like suppose this is the part which needs to be manufactured into a small batch, so we can use 3D printing for batch production. Then we can use 3D printing to reduce the overall product development cycle time. So if we talk about the conventional process, the conventional process is like, first we are going to ideate the design, ideate the part, then prototype will be made, which will be followed by manufacturing, then assembly, distribution. From assembly we will distribute a part, it will go to the warehouse, retail, and finally it will go to the end user. So this is the overall product development cycle for whenever we are planning to develop any product. So this is the conventional cycle which is mostly been used in the to develop any part. But if you're using a 3D printing process, so we can directly from idea we can generate a CAD model, we can generate a virtual CAD model, and in the virtual CAD model we can do the design iterations. So whatever the design iteration which we needed to make the final product, so like those things can be done virtually there itself. And once we have a final ready to market design ready with us, then we will print the we can print that design and directly give it to the end user for the testing or the end purpose. So likewise we can eliminate the middle processes, and we can save a lot much of time and the resources which are being needed in the product development. Then 3D printing, with 3D printing we can make such kind of complex shapes for tooling and pattern making. So like for casting, if you want to have any patterns, or for the rapid tooling if you want to have any patterns, we can definitely use 3D printing technique for that. Then customization, with 3D printing we can do the mass customization. Like suppose if I want to customize a particular product for the masses, so we can do it quite easily and optimum with optimum resources by using 3D printing technique. If I want to do the same with the conventional process, so for each and every individual product which needs to be manufactured for the custom person, or for the custom need, so those every product will need a mold. If you're manufacturing it with the injection molding process, every product will need a different mold. So likewise n number of molds will be prepared, and n number, like with each mold different parts will be printed. So to cater each and every one, individual mold needs to be manufactured with a conventional process. But with 3D printing we can do this design customization within the virtually itself by in the CAD model. And once we do the design customization in the CAD model and we get the final design ready for the print, then we can print the part and give it to the user for the customization. So that's how we can solve the customization problem. Then we can make a creative kind of and customized design for the end user. Again the same thing, like if you want to make such kind of complicated process structure with the conventional process, so first of all it is impossible to make by using any conventional process. And second, even if we can manufacture a certain kind of designs with the conventional process, so to make the custom need, we need to make individual mold for each and every design what we are manufacturing. So with 3D printing, we can keep our canvas, or we can keep our catalog quite big as compared to the conventional one. So I can keep like hundreds of design ready in my digital catalog, and the user can go through the digital catalog. User can select what particular design they need, like they like what particular design they are interested in. They can select that design, and we can manufacture the design by using 3D printing technique. So that's how, like, we give the user a customization freedom. So we give them a very big catalog to select with the product, and which is actually quite difficult with the conventional process to do so. Okay, so these are the benefits. And coming towards the last one is the waste. We develop very less waste production in the 3D printing process. So if we talk about the subtractive process, subtractive is one of the most waste generating manufacturing process. And in 3D printing, since we are manufacturing the product layer by layer, so initially nothing is going to be there on the platform, and subsequent with the deposition of the subsequent layer, the final part is going to be printed. So final part is going to be printed. So likewise, we can manufacture the part, and we can manufacture the part with a very less waste. Okay. So these are the benefits of the additive manufacturing. So coming towards the sustainable goals of the additive manufacturing. So in order to reduce the overall environmental impact, we need to reduce the use of raw material. So how we can reduce the use of raw material? So if we talk about the raw material which has been used in the FDM technique, so in FDM technique, the basic raw material or the basic plastics which are being used are, we mostly use ABS, then we use nylon, we use PC, we use PETG. So these are the plastics which are being used. So these plastics come from the fossil fuel. So from the fossil fuel, like we are going to manufacture the pallet, then the pallet will be converted into a Then this pallet will be converted into a filament form of material, which we are going to consume and use to make the end product. Then that end product, once we are used to be gone through the end product, the life of the end product is been completed, then that end product will either end up in the open landfill, which is a waste product, or we can recycle the material and again bring back to the manufacturing where the pallets are been manufactured. From the pallets again the filament will be made. So this is how we can use the material. We can recycle and reuse the material again and again. And from here, like if we talk about, so this is what we talked about the fossil fuel material. So again, we can also use eco-friendly material like PLA, which is originated from a plant. So we can use the PLA plastic material. So that PLA plastic material will be converted into the pallet, which will again convert into the filament. And from the filament, we will make the end part, use the end part, recycle the end part, and again manufacture the pallet and manufacture the filament. So this is the circular economy. So if we cut and the remaining part which is not being used, it can be thrown away into the landfill. And since PLA is a biodegradable material, so that part can also be degraded into the environment, which is also eco-friendly kind of thing. So if we cut the process from this line, so here we can create a circular economy of the part. And obviously, like we cannot do recycling of the plastic again and again. So we need to mix it with certain kind of fresh plastic to ensure the strength of the plastic. Because with every recycling, every time we recycle the material, certain amount of property are going to be degraded. So likewise, we can reuse the material and we can make the things more and more sustainable. Okay. So another environmental impact is reduced waste. So here, whatever the waste what we're talking about, this is the one of the part where the raw material is being reused again and again. And second thing is, if you're not interested in using the raw materials, then then that part will end up as a waste in the environment. So another challenge here is the reduction of the waste. So if you want to make the overall 3D printing process more sustainable, so we should be focused on two things. So first is the recycling of the raw material, and second thing is the reducing waste material. So how we can reduce the waste? Like if I show you this model, this image where we can see the 3D printed failed 3D printed parts. So this failed 3D printed part, we cannot give it to the end user. So obviously this part we can either convert it into the pallet, which will again convert it into the filament form, or this will end up into the open landfill as a waste product. So to reduce the waste, we need to reduce the print failure, the chances of print failure. The less print failure is going to be there, the lesser will be the chances of developing the waste product. So how we can reduce the chances of print failure? So again, that is one of the most challenging tasks to reduce the print failure. So if we talk about the print failure, why? So first of all, we should know why print failure is occurring. So is it due to like if the printer is not working properly, or if the printer is not been calibrated properly, or is it like the parameter, the G code what we have generated? So is it due to the G code, like we have not generated the optimum kind of G code for the 3D printer by which we can manufacture the part? So we need to find out these two ways. So to reduce the print failure, we should always focus on two things. The first one is the 3D printing calibration, and second one is the process parameter which are being used to generate the G codes. Okay. So to reduce the weight, if my printer is calibrated properly, then second thing is we should always focus on the parameter which have been used by the while developing the G code. So this process parameter, like we should use the optimum values for the process parameter while generating a G code. If we are using the optimum kind of process parameter while generating the G code, then the chances of failure are going to be very less as compared to the are going to be very less. Okay. So what exactly are this process parameter? So I'll come to that. So we have a different set of process parameter for the FDM kind of 3D printing processes, which needs to be for the FDM process, which needs to be optimized. So the first thing is the printer size. So in the printer size, the overall dimension of the printer needs to be defined properly, whatever the kind of a printer what we're using. Like in the market, there are plenty of 3D printers available into the market. So we should, and even the software what we use. So we mostly use the Cura or 3D slicers, slicer software to generate the G code. So these two softwares are been supported by almost all the 3D printers which are available, FDM kind of 3D printer, which are available into the market. So suppose we should configure the 3D printer properly to generate the optimal kind of G code. Like for example, suppose if I'm using Creality Ender 3 3D printer, and in the machine printer size setting, I have used something else. I have used Creality, let's say Creality. Sermon 3D printer is also there. So I have selected a printer as a Creality Sermon 3D printer. So both the 3D printer have a different kind of build volume. So if build volume is different, obviously the basic settings of the 3D printer will be different for both the things. So if I am generating a G code for the Sermon 3D printer and I'm using that G code to print on the Creality Enter 3D printer, obviously the part is going to fail. So for that, the first thing is like we should always choose a proper size and the proper type of the 3D printer what has been used by us. Okay. Second parameter is the layer thickness. So again, the layer thickness has a very crucial impact on the 3D printing. So if this is the rabbit or the bunny, this is the rabbit which we need to print. So if I'm printing it with a thick layer, so what is happening with the thick layer? The part has been manufactured with a very rough kind of surface finish, as we can see on the face. Very rough surface finish is there, and but thick layer has a beauty that the print time, very less print time is going to be needed to make the part. But if you printing it with a thin layer, so here we can see the surface finishing can be reached, is going to be improved a lot. We won't get the exact surface finish of the CAD model, but the stair stepping effect are reduced a lot. So surface finish is quite smooth as compared to the thick layer, and this is a high resolution kind of printing. But obviously, with the thinner kind of layer thickness, the print time is going to be increased a lot. So the solution for this, so if you want to have a good quality of 3D printer and we don't want to waste time on the 3D printing, so the solution is the adaptive kind of adaptive layer slicing. In adaptive layer slicing, so whatever area where we don't need a good surface finish can be printed with a thick layer. So the area where surface finish is the crucial, where surface finish is very important. So we can slice that part with the thinnest possible layer. So this is known as adaptive kind of slicing. If we are using adaptive slicing, again we can optimize the overall print time, and with overall optimized print time, the total energy consumption which has been needed for the 3D printing will be reduced. So this will make the entire process more and more sustainable. Then we have a print speed. So even the print speed has a very crucial impact on the surface finish of the part. Like suppose this is an owl which has been printed. So we have printed the owl at a different print speeds like 10 mm per second, 15, 30, 60, 90, and 120 mm per second. As you can see, as the print speed is increasing gradually, the surface finish of the printed part has been reduced drastically. So with the slowest kind of printing, almost all the features have been preserved, and it shows a very high quality and detailed kind of print. But with 120 mm of 120 mm per second of print speed, we can see almost all the details have been lost, and even many side like some kind of voids are been generated. So this print speed also needs to have a very optimum kind of a print speed. Sorry. So this print speed also needs yeah. So we need to have an optimum print speed while manufacturing the part. So with optimum print speed, we can also try to improve the print quality and reduce the chances of failures. And with the reduction chances of failure, again we are making the process more and more sustainable. Then we have a travel speed. In the travel speed is nothing but the speed of the nozzle when the nozzle is moving in no print zone. So this is a suppose this is a no print zone. So if my nozzle is printing from this point to this point, so what will happen when the nozzle is moving in this direction, in the x direction? So this is the point where the material extrusion will start. So this is the point where material extrusion will start. It will extrude the material till this point, and at this point, the material extrusion will stop. Then the nozzle will move from this end to this end. Again, at this point, the material extrusion will start, and it will keep on extruding the material till this point. So this intermediate space is known as the no print zone, no print area. So the speed at which the nozzle travels in this no print zone is known as a travel speed. So again, if we are increasing the travel speed, so we can see such kind of threads are being formed onto the 3D printer. Then we have a bed temperature. So bed temperature is crucial to make the part stick onto the bed. So we need to heat the bed closer to the glass transient temperature of the material what is being used. So whatever the material what you're using, like suppose if you're using PLA material, then we should always heat the bed to around 55 degrees Celsius, since PLA has a glass transient temperature of almost all 50 degrees Celsius. So we can reduce the sorry, we need to heat the platform closer to the glass transient temperature. And if you're printing it with the ABS material, ABS has a glass transient temperature of 100 degrees Celsius. So we usually keep the heated bed platform the platform temperature near about 90 to 105 degrees Celsius. And even the nylon has a TG of 105 degrees Celsius. So again, the same thing for the nylon as well. We keep the platform near about 100 to 105 degrees Celsius. So the closer the temperature will be, the higher will be the chance of the part getting properly stick onto the build platform. And if the part is not been stick to the build platform, the part will be removed from while printing, the part will be removed from the build platform, and again the chances of failure is going to be there. Okay. Then next parameter is the infill density. So infill density is nothing but controlling the overall porosity of the part while printing. So to improve the porosity of the part, like we can change the porosity of the part which has been printed. Like here in the image, we can see the first part has been printed with 50% porosity, followed by 70% porosity, and which has been followed by again 90% porosity. So the same part with three different infill density or three different porosity. So the beauty is, like, if we can optimize the infill density or porosity of the part properly, so we can reduce the material. We can reduce the use of the material which has been needed to print the part, as well as the time which has been needed to print the part. So these two things will be resources can be optimized. Then next is infill pattern. So like once we have decided optimum kind of porosity what needs to be printed, then we can also optimize the pattern, the porosity pattern which needs to be printed inside. So we have a different kind of porosity patterns which are available there in the software. So from the pattern, we can choose a particular pattern and we can use that pattern for the 3D printing. Then comes the first layer speed. First layer speed is also one of the most important thing. So if we are not using a proper kind of first layer speed, then what will happen is, like, the part will not get stick to the build platform, and it will be removed from the build platform, and again we need to restart the print. So every time we restart the print, we are consuming more and more energy, we are consuming more and more resources, and we are making the process non-sustainable as compared to the conventional one. Then flow rate and the feed rate. So flow rate and feed rate are also important. So these are nothing but the amount by which the material is been feeded into the extruder assembly. So extruder assembly is a block in which the material will be feeded into the wire form, and molten material will come out from the nozzle. So in that nozzle, in that assembly, we need to optimize the input as well as the output from the nozzle. So whatever the input, what we are feeding, the wire which we are feeding, the rate by which the wire has been fed into the assembly and the rate by which the material is coming out from the heated nozzle. We need to optimize the ratio between these two. So suppose if we are not optimizing it, what will happen if we are overfeeding the material, like if the feeding is too fast into the extruder assembly. So excessive amount of the nozzle assembly will try to overflow, and it will ultimately block the nozzle. It will choke the nozzle, or it will choke the and overall system. Okay, and if you're not feeding the material with a proper rate, so what will happen, the molten material which is there within the extruder assembly, it will finish early, and we won't have a sufficient material to melt within the extruder assembly. So we always need to optimize the feed rate into the 3D printer. Yeah. So these are all the process parameters what we can use to make the 3D printing parts. So now I'll try to show you this process parameter onto the software what we usually use. So this is the Cura software which we going to use to generate the cheat code. So whatever the parameter what I have shown you here to print the part, to optimize the to print the part with the optimum thing. So I'll try to show all this parameter onto the software. So this is the overall Cura software. So the first thing is we need to set up the printer. So in order to set up the printer, I'll click on this setting button. So these are the buttons where all the features are going to be there, and this is the area. These are the button where we are going to feed all the parameters of the software. So first of all, we will need to set up the printer. To set up the printer, I'll click on the setting button. I'll click on the printer, and I'll click on the add printer. Once I click on the add printer, I have a non-network kind of printer. So I'll click on this button, the drop-down menu will open. So in the drop-down menu, it is asking me to select the 3D printer manufacturer. So suppose I have a Creality Enter 3D printer with me. So I'll search the Creality manufacturer. So this is a Creality 3D. And these are all the different kind of 3D printers which have been manufactured by the company. So from this list, I'll select the 3D printer what I have. So I have Creality Enter 3. So I'll be looking for Enter 3. Yeah. So I got a 3D printer, and now I'll add it. And next. So once we have selected the machine, we did the machine setup. So this is the overall build volume of the 3D printer what we have. Okay, it will show the overall build volume in X, Y, and Z direction.
Once,
This
hello,
much
sir.
area.
There is a network issue, please, sir. Check once.
Okay, now just a second.
You are not audible, sir.
Am I audible to you, sir?
Yes, yes.
Now, okay.
Hello, sir.
So this is the overall build volume what we have. So this is the volume which we can in which we can actually print a part. So the first thing is we need to load the CAD model into the system. So in order to load the CAD model into the system, I'll click on this open, and I'll select the CAD model which needs to be printed. So suppose this is the CAD model which needs to be printed. So the next thing is to set up a build area, to set up the part within the 3D printer. So to do that, what I can do is like I can choose where exactly I want to print the part onto the build platform. So I can keep the part there. So this is the overall X, Y, and Z platform where I can print the part. So suppose if I want to print the part exactly on the center of the bed, so here in this X, Y, and Z direction, I'll select the value 0 and 0 and 0. So now the part will be printed exactly in the center of the part. Now second thing is we need to do the orientation of the part. We need to select the orientation such that minimum support can be generated. So here in this model, I can show you that whatever the red mark is been shown here. So in this area, the support is going to be needed. The support generation will be done. So again, we can see here, suppose in the
Participants, please be online. Piyush sir will be join us shortly. I think there was a network error.
now, am I audible to you, sir?
Yes, sir. Yes, sir. No, it's correct.
Yes, sir. Okay, I'll again share the screen. Is it visible, sir?
Yes, sir. Yes, sir.
Okay, I understood what is happening. So I'll try not to move the to move the file quite fast. I'll keep it as a slow movement. So here I just need to reorient the part. So whatever the red area which is being shown onto the screen is the area where the support will be generated. So if I show you with this orientation, I don't want support inside the circle, inside the cylindrical area. So what I can do, I can rotate the part such a way that this circular area won't need any kind of support. So to do that, I'll select the part. I'll click on this rotation button and I'll rotate the part. Okay. So now we have rotated the part. Now again, if I show you the model, now you can see inside the circle, the red portion, the red area has been eliminated. It has been removed. So now it is showing that it don't need any support structure to make the part, but the support structure will be needed on the beneath the model. Okay, so this is the red area where the support will be generated. So still network issue is there. Hello.
No, sir, your presentation is visible.
Yes.
Okay. Okay. Yeah.
Hello, sir.
Yes, sir. Yeah.
Yes,
Sorry, sir.
you are okay. Okay, sir.
So now we can see like on the inside area, we don't need any kind of support. So this is the optimum kind of orientation what I have selected. Now I'll try to I'll try to feed the parameters which we need to make the optimum kind of G code so that we can reduce the chances of the failure. So for that, so just a minute. Yeah, sorry for the disturbance. So this is the part. So abhi kya, now the next thing is we need to use the optimum process parameter. So the first process parameter here is the quality, where we will choose the optimum layer height. So the first one is the layer height, which we need to select. So suppose if I want a very good surface finish, so I'll be printing this model with a layer height of 0.1 mm. If I increase the layer height, what will happen? The surface finish will be reduced, and the time is also going to be reduced. But if I increase the layer height, if I reduce the layer height, the surface finish will be increased and print time will be increased. If I decrease the layer height, like if I'm using it printing it with a layer height of 0.2 mm or 0.3 mm, then overall surface quality is going to be deteriorated, as well as the print time is also less time will be needed to print the part. So to get a very high quality of print, I'm using 0.1 mm as a layer thickness. Second is the infill. In the infill, we can, if you want to change the infill density, so this is the option from where we can change the infill density. So suppose if I need this part to have a very good strength, so for that I'll be printing it with 100% infill. Suppose if when I choose the 100% infill, here in the infill pattern we can see only from here we can choose the different kind of infill patterns what we want. But with 100%, it will by default use the line pattern, infill pattern. But if I reduce the infill pattern to, let's say, 40 mm, 40%, 50%, or any value what has been needed, so from for that infill pattern, infill density, I can choose a different kind of pattern which are available within the software. So from this menu, I can choose the optimum kind of infill pattern what I want, and from this button I can use the optimum kind of infill density value what I want. Okay. So I want a very good strength, so I'll be printing it with 100% infill density. Then next is the material. If I open the material tab, here it is asking me to select the print temperature as well as the build plate temperature. Okay, so the print temperature depends on the print temperature and the build plate temperature. This two value depends on the type of a material what we're using. Suppose if you're printing it with ABS kind of material, for ABS the print temperature usually is around 220 to 230 degrees Celsius, and the build temperature is around 90 to 100 degrees Celsius. And for PLA material, for PLA, the printing temperature is around 200 to 210 degrees Celsius, and the build temperature is around 50 to 60 degrees Celsius. So suppose if I'm printing it with ABS kind of material, so for ABS, I'll be choosing a print temperature as a 230 and the build temperature as 95 degree. Then next tab is the speed. In the speed option, I'll be choosing a printing speed at which the part needs to be printed. So for ABS, the optimum printing speed varies from 50 to 70 mm per second. So suppose I want to print a part at a sprint speed of 60 mm per second. So I'll be choosing that. Then here again, it is asking me to choose the travel speed. So the travel speed is like for ABS material, the travel speed is around 70 to 90 mm per second. And if I'm using it with if I'm printing it, the PLA material, even for the PLA, the travel speed is same 70 to 90. And the print speed is also same for PLA, 50 to 70 mm per second. So from here, I'll be choosing the travel speed. Then the next is support. So within the support, since here we can see the red area where support needs to be generated. So I'll simply click on the generate support button. So it will automatically generate the support wherever the support has been needed. The software automatically will calculate the area where the support has been needed, and it will generate the support. Then we have a print bed adhesion. In the print bed adhesion, it is asking, we have a different type of adhesion, like we have a skirt, prim, and raft. So in the skirt is nothing but a printing, like whatever the first layer outline we will have. So we will offset that outline with a 10 mm or 15 mm value. That value we can define it within the software. So we usually offset it by 10 mm, and that outline will be printed first. Then then after that, once the outline has been printed, subsequently the layer printing will start. So that is what is happening in the skirt. If I'm printing it with the brim, in the brim, the outmost boundary of the first layer will be offsetted by 10 mm, by 5 mm, 10 mm, whatever the value what we choose there. So uh, by using that, like if I'm using the skirt, so from here I can choose the distance. Like suppose I want a skirt at a distance of 10 mm, 15 mm, 20 mm, so I can choose that value. If I'm choosing a brim option, so in the brim it is asking me the overall brim width, like by how much the outer layer needs to be offsetted, so that we can define here with the brim width. In the raft, if I'm enabling the raft, so we will generate an entire new layer beneath the first layer. So that is what is happening in the raft. So I'll be choosing the skirt option here. And now we have inputted all the process parameter within the software. So once we have inserted you like we have defined all the parameters to generate the G code, we just simply need to click on the slice button. So now once we click on the slice button, after clicking the preview button, we can see the layers. So these are the layers which will be printed. And total 284 layers are there. So this center part, this outline are nothing but a support material. And this one is the part material. So this is how the model will be constructed layer to see if I want to simulate a nozzle movement. If I press this button, I can simulate a nozzle movement. So this is how the part will be fabricated. So this will be the nozzle movement. And now it is infilling the in between layer. So first it will create the contour, then it will contour with the infill layers. Okay, so now the G code has been generated. So we just need to click on this button, save to file, and we can save the code either in the pen drive or the memory card, which has been supported by the 3D printer. So once we save the G code into the memory card or the pen drive, then we just need to transfer the transferring device to the 3D printer, and 3D printer there we will select the part, select the file which needs to be printed, and we will start the print. So the printer will start printing the part as per the G code. So this is how the overall 3D printing process works. And with the optimum kind of resources, like the more the failures are going to be there, the more energy consumption is going to be there, the more overall consumption of the resources are going to be there, which ultimately makes the process non-sustainable as compared to the conventional process. Suppose by using 3D printing technique, if we are able to save at least 40 to 50% of the overall resources which are being needed to manufacture a certain product, as compared to the conventional process. Like if I'm manufacturing a pen by using conventional, for example, if I'm manufacturing a pen by using conventional technique as well as a 3D printing technique, with 3D printing technique, if I am able to save at least 50% of the resources to make the part. The resources can be in terms of raw material, in terms of energy consumption, in terms CO2 emission, in terms of the waste which has been generated. So if I could be able to save at least 50% of the overall resources, then we can say the 3D printing is more and more sustainable as compared to the conventional process. But if we are not using the optimum kind of process parameter, so what will happen? The chances of failure will increase a lot. So repeated failure, we will again reprint the part again and again. So with repeated kind of printing job or printing with repeated kind of printing will ultimately increases the consumption of the resources. So whatever the resources what we saved with the 3D printing, the approximate 50% of the resources what we save with 3D printing, it won't have any chance there. So that's why we usually say, like, if you want to make the process more and more sustainable, so we should also focus on the process parameter. So these process parameters are one of the most crucial thing to make 3D printing more sustainable and more viable. So with this, I would like to conclude today's session. So if you have any doubt regarding the 3D process, regarding the sustainability of the 3D printing process, so you can ask me. I'm here to try to solve the answer with the best of my knowledge. So with this, sir, I'll hand over the session to you for the further discussion.
Thank you, sir. From participants, any question from your side? Any question?
Hello.
Hello, yes, sir.
Yeah, good evening, sir. The
Good evening, sir.
presentation was nice. And
Thank you, sir.
one question that what do you think that what is the biggest challenge for the successful implementation of the additive manufacturing in industry, according to you?
The biggest challenge is, like, we have three challenges here. So the first major challenge is the availability of the material. So if we don't have like 3D printing material, what we have right now are ABS, PLA, nylon, PETG. So these are the most normal or the common use material. But this material don't withstand the actual end user kind of pressure, or whatever the forces or the stresses will be generated on the end part. So this material don't withstand this kind of pressure. So we cannot use this material as an end product many a time. So material is one of the major challenge. And second thing is the timing. So suppose if I want to use 3D printing for the mass production, so we cannot do that. So we can do that, but we cannot compare the timing with the conventional process. Like suppose if I want to make 100 chairs, so
Okay.
one chair will be taking, depending on the process parameter, one chair might take at least 8 to 10 hours to get it printed. Whereas if we talk about the injection molding process, so one chair can be manufactured within a time span of at least 4 to 5 minutes. So we can see, like,
Okay.
from there, one process, one single quantity is been manufactured in 5 minutes, and here one quantity is manufactured in 10 hours. So for such
Okay.
kind of mass production, 3D printing is one of the major challenge in the industry, and material is also the major challenge.
Okay. Okay. Right. Right. Thank you, sir.
Thank you, sir.
Sir, can we done a post processing of adaptive manufacturing part?
We usually do the post processing of the additive manufacturing part. So in the post processing, it depends on, like, suppose if you want to have a very super finish kind of geometry, like what we can have those kind of super finish geometry, but those need a very high sanding operations, or the post finishing operations needs to be done there. And even we can paint the part, we can do the sandblasting and improve the overall surface quality of the part. So this post processing needs to be done there.
Can we use waste materials for this adaptive manufacturing? Any
Waste material like what, sir?
sir, like anything waste material which not used for practically?
We can use that. So few, like, if we can there are few companies who are actually using the waste plastic and that
Yes.
waste plastic has been converted into a pallet form first, and then that pallet form is again converted into a filament, which can be used by the 3D printer. And there are few research papers, or there are few people who are actually converting the plastic, the PETG bottles, this Bisleri bottles, Coca-Cola bottles, the plastic bottle. So they are converting that plastic bottle into a pallet form, and then they're using that pallet to make the filament, which again can be used to make the 3D printed part. So this is the use of waste material from the plastic. Even there are few people who are actually trying to use the agricultural waste into a 3D printing process. So they are finding out the way by which they can combine the agricultural waste or the byproduct from the agriculture, and they can make a composite with the plant-based plastics. So there are people who are actually trying to do that. So by using this kind of composition or the composite, they are using the waste material.
Thank you, sir.
Yeah.
Participants, any
Someone have
questions?
someone have posted on the chat box how formative process use more resources that than subtractive and additive process. Okay, so basically if we talk about a formative process, so in formative process, suppose if I want to make a part, so the first thing is I need to have a mold. Okay, then in the mold we will pour the material, we will pour the molten plastic, and then we will make the part. So if we talk about the overall process, so we can bifurcate a process into two different parts. So first part is mold preparation and mold manufacturing, and second part is the actual end product manufacturing, where the plastic will be molten down, and it will be converted into a end product or the finished product. So the energy consumption will be needed, it will be needed to make the mold as well. So that mold will undergo the machining process, or it may go undergo the casting process. When we are making the mold, we are using certain kind of resources there as well to make the mold. And once we make the mold, after burning all the resources, we have manufactured the mold, then we are using the mold to manufacture the end part. So during that process, again we are melting the plastic, and we are using the resources to melt the plastic. So that's a double kind of a resource using process. That's why formative process uses more resources than as compared to the subtractive and the additive process. And second question, what Upen is asking, if PLA is biodegradable, then the printed part is also likely to degrade with time. Can we protect it and make? Yeah, PLA is biodegradable, and the printed part are likely to get degraded. And to increase the life of the product with the PLA part. So while making the PLA plastic out of the plant resin, so we can add certain kind of additives there, which can reduce the rate of biodegradability within the environment. And if we can enhance the biodegradability, like if we can reduce the biodegradability rate, we can increase the life of the PLA part. So that is actually been happening in the industry. So initial PLA, what we were getting like a 5 to 8 years back, so that PLA was not having a very good life. So that PLA was having a lifespan of around 2 to 3 years, but now the PLA what is coming into the market, it has a very good lifespan. So people have started using those kind of additives to improve the life of the printed part. Yeah. So I hope when you got your answer. Uh, so any more questions from the participants, sir?
Participants, any questions from your side?
Good evening, sir.
Yeah, good evening, sir.
Myself, Dr. B.S. Buller from Shir Baksan University.
Ji, sir.
So, my question is how we can achieve artificial intelligence through additive manufacturing
I didn't
in
got your
future?
question, sir. Can you please repeat your question, sir?
Sir, how can we achieve artificial intelligence in
Okay.
future through additive manufacturing?
Okay. Yeah. So we can use artificial intelligence in additive manufacturing in two ways. So the first is we can use the AI to optimize the design. So suppose like we talked about the design topology, where we can remove the excessive material from the design, and we can optimize the part weight of the part. So those design topology optimization can be done by using additive artificial intelligence. Even on the second side, the parameter what we have discussed right now to reduce the chances of the failure. So if the user is expert, so what will happen? The user will select a proper kind of optimized parameter so that the part print failure chances will be reduced. But what will happen if the user is new? If the user is not aware of this process parameter, so in that case, the chances of print failure are going to be very high. So there itself, if we can use the artificial intelligence, so maybe we can suggest the user if like once the part is been called within the build platform, so the AI can visualize the part. He can The AI can recommend to the user that this part can be kept in such and such orientation, so that the minimum support and maximum strength can be achieved. And if you are printing the part with the recommended parameter what AI is suggesting, so we can reduce the chances of the failure of the printed part. So that's how we can use AI in 3D printing.
Okay. Thank you, sir. Thank you, sir.
Yeah, thank you, sir. And Arin is asking, what is the best way to calculate a final product weight without using the software? If you want to integrate the calculator on the website, is it possible to calculate the weight? I'll have to check, because one thing I know is like SolidWorks. In the SolidWorks, if we go to the visualize command, in the visualize command, it will show you the weight of the part depending on the material. The weight of the part also depends on the type of a material what you're using, because different material have a different material density. With different material density, the weight of the part will change. So in the SolidWorks software, in the visualize command, if we select a right kind of material, which will be the which we will use for the end production, if we select that material, then we can somehow get a approximate weight of the part there. And I'm not aware if we can integrate that part as a calculator on the website. Yeah, on the website, one thing can be integrated is like this slicer software. When we have sliced the model, so on the beneath side, along with the time, it shows the overall weight of the part, the overall weight of the part which has been needed for the 3D printing. So with that part we can integrate it with the website.
Thank you, sir.
Yeah.
Thank you,
And
sir, for this wonderful session. Thank you very much.
thank you, sir. Thank you for the opportunity, sir. And one last question from the Venkat, sir. Ultimaker Cura is not a designing software; it is a slicing software. For designing, we can use any CAD designing software like SolidWorks, Creo, Proe, Fusion 360. Any kind of designing software can be used. Yeah.
Thank you, sir. Thank you very much for this wonderful session.
Thank you. Thank you so much, sir, for the opportunity.
Thank
I
you,
hope
sir.
I have addressed all the issues from the participants, and I try to share the knowledge, best of the experience what I've gained from the industry with you.
Yes, sir, it was great session.
Thank you. Thank you so much, sir.
Thank you, sir. Thank you. Let's move.